All right, well, welcome to our workshop. This is Turning Your Electric Vehicle into Portable Power. I'm Alex Brown. I'm the Vice President of the Central Jersey Electric Auto Association. I'm here with Stan, who's the President, and we're going to be demonstrating as well as explaining how to power your home in an event of an emergency with a small portable inverter attached to your electric vehicle. The Central Jersey Electric Auto Association, our mission is to promote electric vehicles and renewable energy. We do a lot of green fairs and car shows. We love to talk about our cars. So if you have other questions about electric vehicles, please feel free to reach out to us on our website. The link is on the last slide. So why would you want to use your electric vehicle as a power generator? Of course, it has many benefits. It's much better than a gas generator because it's not smelly, you're not polluting, there's no noise when you're running it, which I think is one of the biggest benefits. An electric vehicle is perfectly quiet, and there's a lot of energy in that battery, and we'll talk about that later. So you don't have to worry about is the generator going to turn on, right? Because I don't know how many times, I don't know if you've had this experience, but how many people have gone out and they haven't used the generator in 2 years, right? So they go out, they turn it on and it's not working, right? So these are all solid state electronics. They're much more reliable. Another reason is not only does it give you power at home, but it gives you power on the go. And this was an event in 2019, the Edison Street Fair, and you can see my Volt there on the right. It's providing the sign, I don't know if you can see the sign, but it says this car provides quiet 100% renewable power for RC4U. So the booth next to me was a remote control kind of a slot car race booth where the kids could race the slot cars. And we provided all the power for that, and that was one less generator that they had to use. And as a side note, I have a secret dream. Someday when you go to street fairs, you will not hear any generators or smell any nauseous smoke as you're experiencing the street fair. I know it'll happen someday. And also when we go camping, right? It's so easy to turn on that power, tap into it, have that cup of hot coffee, you know, bring the computer, get some work done, you know, bring some fans, I don't know, whatever you would need power for when you're on the go. So how does it work? So electric vehicles have 2 batteries in them. The big battery is about 300 or 400 volts, and that's in green in the diagram below. That's your traction battery. That's what stores all the energy that makes the car go. The 12-volt battery is a standard car battery, and that's usually under the hood, and it has normal battery terminals that you can jumpstart or use to jumpstart somebody else, and that runs the electronics in the car. The Teslas are a little different. Sometimes the 12-volt battery is in a difficult place to get to, but I think they also have 12-volt batteries. And so what happens is these cars don't have alternators to charge the battery. So as your 12-volt battery, the voltage drops, there's a DC to DC converter under the hood of your electric vehicle that keeps recharging the 12-volt battery from your traction battery. Now, that DC to DC converter has a certain amount of capacity that it can handle, and you want to make sure you don't go over that capacity or you might run into all kinds of problems. Okay, so what can you power with a small inverter? You're not going to run your house air conditioner off of your car, right? It just pulls too much power. So what kind of things can you run? So we made a list here of some things. Lights, lamps, most LED lights are not an issue at all. Computers, internet, routers. We were running all of our computer equipment and routers and chargers off of our car during Isaias, Tropical Storm Isaias that recently occurred. You can run refrigerators and freezers, but if they're newer, it's better. If you have a really old one, you might have an issue, I don't know. But most people's refrigerators will be fine. And we run our boiler, which is a natural gas boiler in the wintertime. It just has some circuitry and things like that. It doesn't pull a lot of power. If you're running a heater that has a 240-volt blower on it, like a furnace, then that might be an issue. So that's in the list of things that you can't do. If anything that takes 240 volts is going to be a problem. Microwave, if it's a small microwave, you might be okay. If it's a big microwave, I wouldn't recommend it. You got to do some calculations to figure out if it's going to work for you. And you might be able to do a small sump pump, maybe if it's 800 watts. If you've got one of these ones that's like 1,500 watts, it's probably going to be out of the range of what your car can handle. All right, any questions about appliances that you could power, anything like that? Okay, and now safety. Safety is very, very important. When you're connecting the inverter to your car, you want to make sure you have short protection, right? So if you've ever read the manual to your car when they talk about the jumper cables, right? They're super specific about how do you attach them, right? They're like, first you put this one on this one, and then the other car gets, you know, and there's a reason for that. You don't want to short your battery. It's dangerous and it can cause problems with the car. You might blow a fuse or something like that. So when you're connecting the cables to your battery terminals, you want to be super careful about the other end of those cables and what exactly is happening there. When you have the inverter connected, be cognizant of the weather and things like that, right? Because if you have the hood of your car open and you're in the middle of a tropical storm trying to power your house, then you're not protecting your inverter against the weather. And that could definitely be a problem that can cause shorts. And again, you might blow a fuse or something in your car, and then you're really going to be in trouble. For the wire size and lateral terminal connections, you definitely want to be AWG 10 or less. I think I'm on 6. I'm using AWG 6 at least. But follow the rules. You can look it up on the internet. Just follow the rules. You don't have to be at 2 AWG, you know, or anything like that, because the wire lengths are generally shorter for the DC cables. But the DC cables, they pull a lot of amperage, so you need to have beefy wires for those. Okay. And never ever touch the orange wires in your electric vehicle, right? Those are not the wires you should be tapping into. Those wires will kill you. Okay, so don't go anywhere near anything that is orange in your car. Stick to your battery terminals for the 12 volt. And for home wiring, if you're connecting into something on your home, you never ever want to take the cover off your home breaker box when the main breaker is active. If you're trying to tap into some breakers there, that will kill you. The wires that come into your breaker box will kill you. So be super careful in there. If you don't know what you're doing, don't take off the cover of your breaker box. And always isolate any circuits that you're connecting for your home to the grid, all right? So what that means is that if you try to tap into one of your lines in your house, and then the power comes back on, right? Now you've got a dangerous situation because the grid is now pumping power into your inverter and probably going to bust your inverter. And it's also a very unsafe situation. So, you know, for the little hack that I did, I made sure to put instructions that you have to turn off that breaker for that line before you connect the generator to it. But even better would be using one of these generator switchover boxes. We'll talk a little bit more about that. Okay, so does anybody have any questions about safety? All right, I'm going to switch over to my phone. And I apologize for the delay. Can you guys hear me okay?
Yes.
Stan, do you want to turn off? I don't know if you can't control the slides, can you?
Caleb?
But you may want to stop sharing the slide.
Yeah, let me see what I can do. I don't know if I can.
Actually, I don't think it's a problem. At least I can put you on my screen, Alex. I can see you, so it doesn't bother me. You got frozen, at least on my end.
Can you hear me okay?
We can hear you somewhat. It would be even better if we can see what you are trying to show us.
I think we lost your video, Alex. And if you're on a desktop, if you just double click on Alex's
Face.
it will work. And I'm sure on the phone you can just select it manually. Oh, I can. I can stop participant sharing.
I think Alex is.
There he is.
Oh, I apologize. That took way too long to connect and everything. Can you guys hear me okay?
Yeah.
Yes, you are sitting in a car.
Okay, yes, I am. This is my Chevy Volt. And you can see here, now I'm going to give you some direction specific to my car, but your car may or may not be similar. But in the particular case of the Chevy Volt, what I need to do to keep the car on all the time is I need to put the car in neutral, apply the parking brake, which is here. So my parking brake is on, the car is in neutral. So I'm ready. The car is turned on. What I do is I just leave the car on the whole time. So now I'm going to come back here to the trunk. All right. Now, in the trunk here, I bought a kit for my car. It's called EV Extend. And the battery in the Chevy Volt is underneath the trunk here. So this is the cover. Can you guys see this okay?
Yes.
Okay. So there's some foam here. There used to be a jack in the car, okay? And so I carved out where the jack used to be, and that's where I keep my inverter. So it's always with me in the car. So I'm gonna pull out the inverter. All right, so here it is. It's a 1,000-watt continuous inverter. Can you guys see this okay? And the kit that it came with some cables here, you can see, and a plug. So I'm gonna open up the side here where the other mated plug is and plug this in with one hand. I've never done it with one hand before. Should be fun. Hold on a second. Can't do it with one hand. Plug's too big. All right, so it's turned on. Now I'm gonna hit the power button on the inverter. The green light means it's on. And now I just have to plug it in. My extension cord. So I'm gonna plug my extension cord in. Again, I apologize for the.
Don't you have kids that could be your camera crew?
Yeah, seriously. All right, so on the other end of my extension cord here, I've got a power meter. One brand is called the Kilowatt, but there are lots of different brands, and it'll tell you how many watts that you're pulling on that plug. So I'm gonna come over here and plug in this incandescent bulb. And I apologize. Okay, now I'm gonna turn the bulb on over here. And we can see that we are generating. Can you guys see that okay? It says 64 watts.
Okay. Yeah, we can see it perfect.
Okay, awesome. Okay, so that's pretty much it. And then, so the rest of the trick comes down to how you power your house, right? So the easiest way to do it is just to get an extension cord and run it into the house and power your refrigerator that way. And we've done that. We did that for a while, and then I tapped into one of the circuits in the house. And I can show you that in a minute. I don't know if I'd recommend it though. But let's just see one more appliance. I'm going to plug in something else, and we're going to just to show that it can handle a higher wattage than that. The unit is rated for 1,000 watts continuous. I have this old humidifier. The compressor on the humidifier still works, so we're going to use this guy.
It looks kind of...
All disassembled, I know. I was trying to fix the fan in it, but I failed. So I plugged it in. And I don't know if I have to hit on. It's plugged in, it's drawing a few watts. I don't know why it hasn't come on.
There is some clicking noise.
All right, well, this experiment is failing here. Well, it worked a few minutes ago. It's not the power, it's the humidifier. So I don't know why this thing isn't drawing power right now. Maybe it's not that humid out, but it's hard for me to believe. All right, I'm gonna move on. So would you guys like to see my hack for the circuit in the basement?
Yes.
As well? Okay. All right, let me run down there. I'm not actually going to demonstrate that though, because my son, who's probably playing video games right now, will be very upset if he suddenly loses internet access. So this is what we call engineering down here, my basement. All right, so up here in the corner, I might need more light for this. I've got, I tapped into this circuit here. Can you guys see that? And I've got some instructions. And then I have a wire coming out of here that has a plug on it, right? So it's one of these plug kits that you buy from Home Depot. And so right now it's got the end on it, which makes it safe, right? Because the electricity can't touch anything because it's closed. And there isn't any electricity flowing through the plug, so it's not a hazard for the house right now. But I would I would turn off the breaker 22, and then I would unplug this and plug my inverter into this, and this will power our boiler circuit in the house. Does that make sense to you guys?
So you have it plugged in one circuit, or do you keep 22 off?
When I'm using the generator, breaker 22 is shut off, so that I never.
So you're only powering one circuit. So whatever's on that
That's
circuit
correct.
has power, which is your boiler blower motor, which is what you care about.
Right, and a better way to do this is to use the generator switches. You can get them at Home Depot. You could have an electrician put one in, and they'll give you the ability to power your entire house. Of course, you can't draw that much power because, you know, like my inverter is only 1,000 watts. So yeah. If I try to run every appliance in my house, then I'm going to have big problems.
So you just for record, is you'd only be able to run half your house because it's only 110, so you'd only have one phase.
That's correct. And I wouldn't be able to power the blowers for my air conditioner. I wouldn't be conditioner. If I had two 20-volt blower on my furnace, I wouldn't be able to power that either.
Yeah. But what you can do is you can backfeed the whole panel, and then you just be selective that you want lights on in a specific room or what have you.
Well, what you would do is you'd probably, when you get the generator switch, I guess you probably couldn't get the whole house. It would just be half of your.
I think you are switching to another router.
Oh,
Ah, you are back here. Okay.
I don't see a picture. So,
All right, so questions.
so how long can you run
I
the
think
power?
we should go to my setup maybe.
Yeah. Do you want me to answer that question while you're on your setup? While you're getting to your setup?
I would accept the silence as a yes, Alex. So the question, Alex, was how long can you run something like a refrigerator on your setup?
Yeah, so Stan made a slide for us here at the end. So here you can see he did some math for us. And my battery on the Chevy Volt, is it 14 kilowatt hours? I think it's 16.
I think it's, yeah, but I think it's the usable amount is only about half or 60% of that, I think. I think they made it 14 to qualify for the full 7,500 tax credit, but then they dialed back the low charge and the high charge state. I think it's maybe 8 or maybe they went up to 10 kilowatt hours.
I have the newer version of the Volt.
Oh, you do? Oh, okay. Yeah, you might have. That's a bigger one. You're right.
Yeah. So I think it's somewhere around 12 to 14. And that will get me at least 2 days. I don't know if his assumption here is that you're at we'll ask him how many, Stan, if you're on the line, how many watts on average is this math?
So this is on the assumption that the average wattage is 300 watts.
That's what I was thinking. And that's about what I was pulling.
And 300 watts is essentially considered, that was a calculation on the previous slide, based on average New Jersey home. The average New Jersey home would use 24 kilowatt hours per day. But if we strip off the heavy duty appliances that cannot be powered, then we arrive to 7.2 kilowatts, which means 300 watts in average. But that also means that you can have much higher peak. Some of the appliances that are cycling, including fridge, fans, sump pump. Yeah.
All right, Stan, do you want to go ahead?
So we're actually a drawing off of the traction battery.
Yeah.
So
exactly.
so in my 2020 Bolt EV, I should have a huge amount of power there.
Yeah, yeah. You several days worth of power. We'll go back to that slide in a minute. Stan, are you ready?
Yes.
I stop my sharing.
I am. Can you hear me?
No, you're very faint.
I am now on my device. Can you hear me?
Yeah, we can hear you, but you're a little faint. So.
Good. Now let me switch to the other camera. This is my studio, and so the TV is off. Now what I'm going to do, I'm going to shut it off because I will need to demonstrate how my system works. So
this is my garage. I'm just juggling with another phone because I need to have light. So this is, and let me open the garage. Let me open it electronically. By the way, the garage opener is drawing in average 500 watts. It would also work, but it's completely unnecessary because it can be opened manually. So, and I have already set it up. I can use actually. So in my case, what I have is 3,000 watt power inverter with peak 6,000 watts. The Nissan Leaf has DC-DC converter that has capacity of 2,000 watts. I'm not certain whether it would be happy to be drawing 2,000 watts constantly, but you know, for short periods of time, the small 12 battery buffer. Now I have to show you that in my case, I have deviation in my vehicle. This battery is not original Nissan Leaf battery. It is a lithium titanate battery that is coming from salvaged BMW that had start-stop system, and I got that battery on a battery hookup. It has, I believe, 10. Yeah, it says 10 amp hour capacity.
Yeah.
Advantage of that battery is that it has 20,000 cycles, so it has very long life, and it can work at deep low temperatures. So I'm looking forward for winter. And also it provides a substantial amperage as a peak power. Now in my setup, what I have, and you know, I will refer to all the safety guidelines that Alex mentioned. Here I have my plus, this is minus, but what I have here is this device, which measures the current consumption. So this is voltage, this is current, this is power, and this is cumulative energy. 7,814 watt hours, so 7.8 kilowatt hours. And this is the amount of energy. I have this inverter in my shed, so you can tell how much you know, I have accumulated so far in a few weeks. So the vehicle is off, so I have pretty good voltage. Now, so the first thing is to turn on the vehicle. It's very simple, and this is old 2015 Nissan Leaf. So I press the brake pedal, start, and there you go, right? I have 86%. Do you see it? The voltage is a little bit higher. It was setting for 99, now it's 14.32, and the inverter is still off. So you see that the current and power is off. So on the other hand, what I have is
And we're losing your audio. Can you adjust your audio maybe?
see what happened. My vehicle picked up the audio through Bluetooth. How about now?
That's much better, sir.
Okay. So this plug, it's modified. It's NEMA. Oh my goodness, 550, 520. It's a regular 120 volt, but it can carry 20 amps versus 15. And the reason why I have it, because I just want to match the capability of the inverter with the system. So this is a 10 AWG. I don't see anything. Okay, so I plug it back, and you could see that I was touching the circuit, I mean the prongs, and there is nothing wrong with them. And I show you how I have it hooked up. Now I need the light. So the switch that it's labeled generator switch, for, you know, maybe it's not the right terminology, but I just made the label today. It's off. And so the way how I have it hooked up, that one of the prongs goes to neutral and the other one goes to both legs on this breaker. So should I turn it on, it would immediately trip back because it's shorted inside. But the reason why I have it that way, because when I turn off the main, which is here, and I turn that on, then the 120 volts will be distributed across all circuits.
On that one side, right?
On all circuits, because I'm connecting the legs, right?
Right, but it's all the circuits on one side of your panel, right?
No, the left side is one phase and the other side is the other phase, right? But if the breaker is thick, it's using two-phase system, like you know, the AC heat pump, the range oven.
Oh, I understand.
And everyone's system can look differently. So what I'm going to do, first of all, I'm going to turn on the inverter. And it's pretending it understands how full is the battery. It measures somewhat different voltage, 14 versus 13.8, which is a little detail. 0% load because the idle power is just 12 watts. It's less than 1 amp. This is what the inverter is eating just by being on. And now, and I hope I will not get disconnected because I'm on data. I'm going to turn off the main and turn on this. And the light is back on.
Cool.
This is what I'm drawing right now. 750, about 750 watts. You know, the reason is because it's the whole house. Maybe the fridge is on, other appliances, now it's 140, right? So it's changing. So that's how my system works. Do you have any questions?
Did you install that box stuff yourself, or do you have an electrician do that?
I happen to install the whole box myself. And I wanted to be a good example, and I put the cover back on because it's a safety that we are promoting. So you don't see how it's connected behind the metal cover. Again, one wire, the light is connecting both legs together.
Stan, you're an electrical engineer, right?
No, I'm not.
That's a clever setup. Do you know, Stan, do you know, I believe in Japan, they sell, Nissan sells a kit for powering your home from your car. Is this based on that architecture?
No, no. Let me open. It's dark in here.
So So that's,
Oh, I did not open the hood because the vehicle is on. I mean, the opening port. The CHAdeMO here, okay? This
Right.
is how their technology is operating because CHAdeMO is a bidirectional.
Oh, okay, right.
They're actually connecting directly to the main traction battery.
right.
I see. Okay. Well, you're doing the same thing, but very cleverly through the 12-volt battery. I love it. That's
It's
elegant.
It
Very
is.
elegant.
Thank you for saying this. It is clever for emergency purposes.
Right.
Okay, you don't want to have it on permanent basis. Now I can go back home and oh my goodness, the range is on. I mean,
Nice.
I forgot to tell her. Well, that's what we have seen 700, and it's cycling. So the lights are back on. Honey, can you turn the TV? Just to show you that everything works. It takes a while for the appliances to come fully on. It does, don't worry.
If I could interject,
I have done homework, and I have every appliance in my home measured the wattage. So I don't want to be caught by surprise. You see that the lights come on?
Wow.
This light, the fan works.
now Stan and I are both kind of hackers here when it comes to wiring up the house. If you were to talk to an electrician about giving you some kind of a switch to hook this up, you really need to talk in the language of a generator connection for the house. That's really what you need to be talking with the electrician about.
So before I went here, I turned off the furnace. But the reason is because the AC was just on, and I thought it would be better to do it that way. But I was doing an experiment today. The blower in the furnace, I have forced air. It's drawing about 120 to 130 watts.
Now,
about 300 watts.
but I'm confused as to why is the blower, I guess it's a 120 volt blower. It's not a 240 volt blower.
It would work. It would work actually. Let me show you.
So Stan, the air conditioner couldn't do it just because the first draw of the compressor coming on has too much peak current? Is that why?
Compressor is wired through a two-phase. Let me turn off the light.
Oh, I see. Okay.
But the furnace, it has a circuit underneath. It's a circuit. I've been playing with it. I have another video ready. And it's powered through one phase. And it's a gas. It's actually a hybrid because I have a heat pump on the other. The AC is actually heat pump. Here is the heat exchanger at the bottom. So what I want to say, so the heat is burned natural gas, and the blower is electric, right? Mm-hmm. It's using 120 to 130 watts, and the circuitry is actually included in the base load that I was showing. I can go back. Well, the 290, that includes the TV and stuff. And I pissed off my wife because I turned off the and not only that, I took her phone. So I want to show you one more thing. So this is my shed. And about a year ago, is it 1 year old? No, it'll be 2 years actually. Here I have a solar panel on my shed. It has 150 watts. I put that solar panel by myself. The section of the roof is oriented east, southeast, but mostly east. So I have most generation in the morning. But what I discovered recently, that this is solar charge controller, this is one battery, and from here, I have in parallel connecting to another batteries. So this is 100 amp hour lead acid, and this is, I built by myself, lithium iron phosphate. And here is another inverter. Now this inverter is put here only for the show, but what I have is actually the first one, because this one I'm retiring it. I was running electric chainsaw on it, doesn't work well. However, if I have the other inverter here, plug it in here, then use extension cord and take the 120 volt AC into here, okay? And then this circuit, of course, has to be taken carefully. And this circuit, it's powering the other appliances in the kitchen. But I already traced down which one it is. And hopefully we'll have enough light. I need to label it, yes. It's this circuit. So what I would do if I power it from the shed, and that's the message that I want to say, that I can power my home from that grid shed for a few hours a day. The advantage is that it's actually continuous because the sun hits the roof every day or almost every day. So while the car, it has to be charged prior use. So what I have to do, of course, turn off the main, that's number one. And here, this one will bring the power into one leg. And then when I connect what I call generated switch, I'm taking that power to the other leg. And what happens that my fridge is on the other leg. So if I want to run fridge, I have to use this. But then I have to be really careful because last time I was testing it, I could run only for about 4 hours. Because we were watching TV and stuff. So, and I think, do you have any other questions?
Stan, if you were going to make that setup to your Bolt EV instead of the Nissan, where would you connect?
I'll gladly show you. Wait a second, I have to open the hood. I think I may not have enough light. Let me bother my wife.
No.
Can I use my son's phone?
Look at all those gadgets.
Oh,
It's a sign of the times when only flashlight.
We're gonna buy you a proper headlamp. That's gonna be our gift to you.
so this is the battery in Volt. I'm missing a third end. So under this cover is the positive terminal. So this is where you would put the one terminal, and this is the negative. And that's, don't fall. And that's it. Those are both vehicles are OEM, the traditional brands, and And I believe that the DC-DC converter on this vehicle is also 2000 watts. I would have absolutely no issues of using Volt. It's just that traditionally we park Volt here and Leaf there. And the box happens to be closer to the vehicle park here. And we can peek how much percent we have. Oh, we lost something. Do you see it?
What is it down to?
84. It used to be 86, which
That's
is
because the stove, probably the stove was on.
but it's surprising. But you know, this is a 5-year-old vehicle, so
Okay. Any other questions for Stan?
Would it be possible for somebody at the end of this to put together a list of the equipment and possible costs of where to get them, so we could all have that?
I have it included, right, in the deck. So if we can share it for a moment, it will be part of the recording.
Okay.
And what we will most likely do, we are going to share the deck as well, separately. Okay, I'm going to disconnect from my phone.
Okay, real briefly, I'll just talk about some of the equipment here. So some of the EVs now, or plug-in hybrid EVs, have actual outlets in them now. The one that I know of is the Mitsubishi Outlander plug-in hybrid electric vehicle. So it just has 110 outlets built in for up to about 1,500 watts. Do any of the rest of you who are in this call know of other electric cars or plug-in hybrids that have outlets, 112 outlets built into them? Okay.
I just knew that the Leaf had a kit, and
Okay.
thanks, Dan, for with.
I'm back
saying
here.
that.
My phone was, my computer was disconnected, obviously, because it is on Wi-Fi. So
From what I've heard, the Rivian truck, it's not out yet, but that has native 240 volt.
Yeah, get yours together too.
So does the Tesla Cybertruck, which is not out yet either.
Oh, that has 240 also.
240
Yeah,
as well as 110.
yeah. I think they're going for that next level up where you can power your compressors and your well pump and things like that.
You'll probably find all of the trucks, whoever, I think there's 3 or 4 in the pipeline, they're all going to have it.
Yeah.
Yeah, right.
Where do you find these aftermarket kits?
Okay, so EV Extend is the one that I'm aware of. If you just do an internet search on the other ones, but there aren't a lot of them. You know, you're not gonna, I'd be surprised if there are more than 3 vendors that sell the actual kits that are specific to a vehicle. Like for example, my kit is for the Chevy Volt. It has the plug, the wires are all the exact right length. It had a fuse built into the kit, and the instructions tell you exactly how to connect everything to keep from damaging your car, which is really handy. And it's really handy having that plug, so you can just immediately plug in and get your power instead of having to sit there and futz with battery terminals every single time you want to use it.
I would love to do that for my Leaf.
They do have a kit for the Leaf. But even if you don't have an aftermarket kit, you can always do the kind of thing that Stan was doing. Not as many people do that probably, but It's like using any car. And honestly, you wouldn't even have to have an electric vehicle. I mean, we're just running these inverters off of 12-volt batteries. So even if you have, an old,
Yes, but this is something we really don't want to even endorse. We are the electric people, right?
Right.
Absolutely. But, in a pinch.
Besides, Tesla wants to sell you a power wall so you can put that battery in your garage.
Yes.
Yeah, and that's
I did a similar setup to his with my Leaf, except I'm not an electrician, and I don't even try to do anything electric because I know I'm not trained for it.
Yeah, that's
So
probably
I
most.
don't hook up to my panel, so I just took the inverter and run a few extension cords into the house, and then I was powering like a lamp, and I plugged my refrigerator into it, and just so I had some bare minimal essentials running, and that's it.
Yeah. What kind of inverter do you have?
I forget what it is now, but
1,000 watt, or is it a bigger
it's
one?
like 2,000 watt, I think.
Yeah. All right. Cool. And if you wanted to connect to Tesla, just beware that my understanding is that the Teslas are a little trickier, and you may need some additional circuitry to make that work. And the other thing to keep in mind too with all of these is, if this is something that you're not comfortable doing, keep your DC to DC inverters for a lot of these cars are a little bit expensive. So you could actually put yourself back, for something that you could go just buy some cheap generator for, so that's always something to keep in mind as well. So, Stan, do you want to talk about the slide and the Tesla Powerwall?
Wait a second. Which slide? Oh, this one. Well, so I got this from the internet. So there's a difference between a vehicle to home and a vehicle to grid. And vehicle to home is more for the emergency purposes that we are doing. But for vehicle to grid, the purpose is that you want to feed the grid back from your home, from your car. And the reason why would you want to do it only because the utilities, they give you the opportunity, and you have to be in that jurisdiction, that when power is cheap, you want to charge, and when power is expensive and the utilities, they have problems to get the load back to meet the demand, so you can put the power back into the grid and they will pay you for the service. So it goes back into the question, so why do you want to have a car? Do you want to use it to sell electricity, or you want to have it to drive? So that's why we are focusing today on vehicle to home, and use it only in emergency. When you have a gasoline generator, it needs service. Even with the gas generator, some of them, they have a 12-volt battery for starting. I actually never owned generators, so I don't know whether they're all pull string. But they need spark plugs service. They need to have oil, and are they 4-stroke? And how clean are they, and all those questions that we mentioned at the beginning. So as opposed to having this large equipment in your home all the time, it's better to have just the smaller inverter. Even the 3,000 watt inverter that I showed you, it's smaller than typical gas generator. And I have it in my shed, and I typically power my string trimmer and some other stuff. So although I would not go into details of my off-grid shed, what I'm doing with it, it's a one big exercise for me. And I'm so surprised how much can I power from the 150 watt panel. It's just amazing.
All right, we're starting to run out of time. So
yes.
I'm going to move us along. Did you want to talk any more about the calculations here?
They are pretty much based on the search that I have done. So the traction batteries that we are talking about today are between 16 and 100 kilowatt hours. It's a model dependent. The DC-DC converter, as I mentioned, you know, in my vehicle and the Bolt, that 2000, you don't want to get that far, but remember that the battery gives you the peak power up to 5,000 watts. So for a short time, you can have the spike. So you need to, depending on what is your home, what is your setup, but you have to be very careful to calculate. And also what we didn't mention, you want to pick pure sine wave inverter.
Yeah.
They are modified as well, they're cheaper. You can be lured to buy modified. Don't buy modified because they can damage your equipment. Some of the equipment just don't like it. So you want to have pure sine wave inverter.
Okay.
And you want to have at least 1500 to 2000 continuous power. So next slide. Yeah, we got through that. So this is it.
So like a Tesla has how many?
Up to 100.
About 100?
Yeah, so 14 days. Yeah.
14 days. Wow. That's.
But it has lots of assumptions, this chart. And I have to admit that I ignore the overhead that the vehicle uses, which could be, yeah, it would be maybe 200 watts that the vehicle is using all the time when it's on, because the vehicle has to be on, right? All the power electronics is on, the dash is shining or lit, right? The computers are running all the time. So there is overhead that is required. So these are all estimations. In my case, my home, I have 200 watts in case of emergency. 200 is, and I have to shut off the TV to have 200 watts. So, and for any other questions and for your reference, these are our contact information, our website, cjeaa.org. Caleb, he is maintaining that website. Meetup, I'm not certain whether we want to keep it, but we still have it. Facebook will definitely keep it because it's free. Meetup is not free. That's the problem. And if you would like to donate, all donations are welcome. If you go to our website, we have a link how to donate. You can go to electricauto.org and also donate through that website. And we thank you so much for your attention, for coming here and staying with us.
And let me just add real quick, when this recording is done and processed on the cjeaa.org website, there's a link to meeting minutes. And in that, and on that page, we will have a link to the video for this.
Thank you, Caleb, for taking care of that.
Great job. Thank you.
Yeah,
Great way to
thank you.
start a weekend.
Thank you very
Nice
much.
demo.
Thank you very much.
Have
Thank
a great
you.
weekend. Bye.
Thank
Bye.
you. Bye-bye.
Bye.